right, welcome to Miller World, a three-dimensional space in your brain. Okay, so we're going to talk about points, lines, and planes in space. Okay, but before we start, remember that every compass has a pencil, but that's not the point. I don't know how to talk concepts such as points, lines, and planes without talking about something called dimensionality. Right. Remember, in math, specificity is a necessity. So I have a definition here. This is how we define a dimension in mathematics, right? So a dimension is defined as the minimum number of coordinates
necessary to specify any point within its mathematical space. All right, so yes, if that sounds like
space-time,
it is no coincidence. All right, so we're going to begin our journey of dimensions by looking at a figure that has absolutely no dimensions at all, and that's the mathematical point. But to do that, we're going to have to work on our abs. Yes, those abs. So in math, and especially in geometry, we often have an abstract concept. It's something that cannot actually be seen, it can only be understood.
We take that abstract concept and we come up with a physical representation for it.
Okay, let's look at points. When you think of points, you might think of a coordinate point, right? So I'm going to pick a point down here, and you notice that I represent this point with a dot.
A point is not a dot. A dot is simply a physical representation of the abstract concept of a point. Okay? I could not draw a point because remember, a point has no dimensions. It has no measurements that I can take. It has no width, it has no height, it has no depth. Obviously, this dot has
a measurement.
I can make it larger or smaller.
This is simply a physical representation of a point.
A point has no dimensions, meaning that within a point we cannot measure anything.
So, we've begun to work our abs by looking at the abstract concept of a point, which is a non-dimensional object. The next thing we're going to talk about is a line.
And so if I think of this as a line, it is a straight object that just goes on and on and on, on and on and on, on and on and on, on and on and on.
Again, we would not be able to see an actual line because, think about it, it would be so thin that it would not have any width whatsoever. All right?
there's a line that you guys are already familiar with in mathematics, and that is the number line.
That's a one-dimensional object.
Notice this is my representation of a line. The arrows indicate that it goes on forever and ever, amen.
Forever and ever, amen.
Right, we have our positive universe and we have our negative universe of real numbers.
If I put a point on this line at 5, how many numbers would it take for me to tell you where that point was? Well, in fact, it only takes one number. You can just tell me, I want you to go to point 5 on the line. And that's why
lines have one dimension. Okay. If I say go to -2 on the number line, then you know exactly where to go. I only need to give you one number in order to find a location on a line.
All right.
For our third undefined abstract term, we're going to talk about the plane that we're all flying around on. Oh, not that kind of plane. We're talking about a flat two-dimensional surface. This is a representation of a plane with the exception that this plane
would extend forever and ever, amen, in every direction, okay? Also, a real plane would have no thickness.
Yet you can clearly see that my little whiteboard has thickness. So remember, this is not a plane, this is a representation of a plane.
The floor
that you are standing or sitting on is a representation of a plane, and the walls that surround you are also pretty good representations of a plane. And of course, There's one we work with a lot in math, and it's called
Coordinate plane.
So let's look at that a little bit.
So the coordinate plane includes our number line. We often call this
The x-axis, right? And we call this one the y-axis.
We call this the Cartesian coordinate plane. If I pick a point on my coordinate plane, then that point can be represented by what? Two numbers, right?
Right, so in this case, if I'm counting by ones, 1, 2, 3, 1, 2, we can represent that as 0.32.
So think about this.
If I were to pick any point on this plane, this infinite plane, remember, it also goes on infinitely in all directions with only
Two numbers.
okay, in this case 3, 2, I can tell you the location of a point. This is what we call
Two dimensions.
All right, so to review, we have talked about an abstract concept of a point that has no dimensions at all. We can't see it, we can't touch it, we can't feel it, but we know it exists in our mind, and we can represent it by a simple dot. And we talked about a one-dimensional object, which is a line. A line can be represented by a straight object that continues in both directions infinitely. Any point on that line can be identified with only one dimension, with only one number. And we talked about a two-dimensional abstract object called a plane, and we can think of the coordinate plane. Any point on the coordinate plane can be represented by two coordinates. Thus, it is two-dimensional. All right. So, I know what you're saying, but what about three dimensions? What we might ask ourselves, what abstract object would encompass three dimensions? And the answer is our universe. Okay, so imagine if I take a 3D object and I extend it in every direction forever and ever. That's our known universe. Now, I know what some of you are saying. You're saying, wait, but I heard that time was also a dimension, and that would make our universe four-dimensional. And you would be correct if you take the Einstein approach to our universe.
In that any point in our universe would actually not only have three coordinates for its location, but one coordinate for its time in existence.
But I've gone way beyond what you need to know for your standard high school geometry class.
So let's stick with the three undefined terms.
Point, no dimensions. Line, one dimension. And a plane, two dimensions. Okay?
Make sure to write down any questions that you have and bring them to class tomorrow. And remember, I see math in everything. Everything.